flipping the page, and you got these freshwater, even marine ecosystems, any kind of water ecosystem. I just want kind of a little flow chart in here, just so that we can kind of see the pattern again. But again, this is basically that hydrologic cycle from a while ago that we did. So one major thing, first off, just looking at these three things, marine is ocean. And so there's salt in that water, right? Salt water. Freshwater means that there's no salt on the other hand. And an estuary is actually where those things mix together. So it might be kind of salty, kind of not salty. Somewhere in between. Sometimes actually when you're in one of those places where they mix, you can actually see two distinct layers, two different levels of water, that one is salty, the other one's not. So they can form these haloclines, these little density different liquid, one liquid on top of the other. So understand just what those basic terms mean. This is an estuary is where that fresh water pours out into the ocean and those things are mixing together. So it's like in a delta, like basically the entire state of Louisiana is an estuary to a certain extent. Otherwise, just some basics. So I'll go through this kind of flow chart here. You got watershed that might create a stream. Ice melting on the mountain starts to collect, forms that stream. That stream could feed a river. That river could eventually get out into the ocean. Remember, you have that estuary first, and then you're out in the ocean. So water can get from the top of the mountain, melt off, and end up in the ocean eventually. But you'll know there's other pathways as well, obviously, because those streams and those rivers might actually empty and fill a pond or a lake. You know that ultimately some of that water is going to sink down and fill that aquifer that's below us. You actually know that sometimes that water below ground can make its way back up and start a stream again. But there are just a few things up here that we kind of need to focus on specifically as far as those ecosystems are concerned. I do have one last thing here, I forgot that. That stream, that river can also empty out and kind of form wetlands. You know how Florida is kind of all wetlands, or at least a lot wetlands, where you just have standing water all over the place. It's not really a pond or a lake because it's not deep, but you have water covering a large area of land that's a wetland. So those are some different options as far as ecosystems are concerned, and I just want to point out a few specific things about some of them. First off, these two are pretty important, estuary and wetlands. And they're important because they have the biggest biodiversity out of all of those water ecosystems. They have more different kinds of living things than any other place. So in those wetlands, it's a huge biodiversity. In estuaries, there's a huge biodiversity, lots of different kinds of living things. So they are the most diverse. Whereas when we talked about the land biomes, where was the most diverse ecosystem? Which one had the most different kinds of living things in it? You could flip over a leaf and there'd be a million new bugs we've never seen.
Rainforest.
A rainforest. So if I go backwards one slide here, that's another thing that we could probably point out here. That rainforest is the most diverse of all those different land biomes. But wetlands and estuaries rival with the rainforest to a certain extent. They have a lot of different kinds of living things in them as well. Sometimes they'll call this estuary up here, so just some kind of different mark. The nursery of the sea, because a lot of different things that live out in the open ocean will come into an estuary to lay its eggs if it's a fish, or have its babies if it's a mammal, right? Like a whale might come into a bay to give birth because it's a good protected, sheltered area with lots and lots of food available, typically, right? There's a huge biodiversity again, so there's lots of nutrients, food and things like that available, so it's a good place to raise young animals that eventually would go out and live in the ocean, open ocean. Other than that, our other keys to look at here, right? Wetlands can also kind of sink down and fill that aquifer. But ultimately, we know why that aquifer below us is pretty important. Why is it important? Why?
It's our fresh water source.
Because that's where we get our clean, good water. And places like New York that have built cities on top of wetlands that were originally there, they don't have those ecosystems that provide them with nice, clean, good fresh water. They have to pay a lot of money to get that. So the emphasis you put on that aquifer there again is that it gives us really good, clean water. Oops. Can't spell clean today, apparently. That's all right. So that's obviously something we could emphasize a little bit. Those aquifers are pretty important. They're filled by, to a certain extent, wetlands and or ponds and lakes. Right, as that water sinks down, right, it gets filtered as it's going through the ground. And that's how we get most of our clean water. At least most places do. Some places have to pay a lot of money to get their clean water.